Hi, I am Abu Bakr and I will present our work on Generalized Zero-shot Intent Detection. Intent detection is typically the first step for the dialogue systems towards performing any task and is usually formulated as a sequence classification task. Supervised approaches have shown promising results for the task. However, in practice, unseen intents emerge after deploying the model and they do not have any training data. Whereas supervised methods assume that the labeled training data is available for all the classes, that renders them ineffective. And that motivates our task of generalized zero-shot intent detection. The goal is to develop such a classification model that may not only classify utterances with seen intents or unseen intents, but both seen and unseen, which is a challenging and very critical task for conversational AI systems to function effectively in real world. To take on the challenge, we propose RIDE. The main idea in RIDE is computing relationship metafeatures. These are robust and generalizable relationship metafeatures that capture deep semantic relationships between utterance and intent labels. These metafeatures are computed by considering how the concepts in an utterance are linked to those in an intent label via commonsense knowledge. Knowledge graphs capture a large subset of knowledge in a semi-structured format in the form of head relation tail triplets. Given that knowledge graphs are incomplete, we pre-train a link predictor that learns from existing relations and infer novel relationships. Essentially, link predictor takes in a novel triplet and provides it a score between 0 and 1. Given a natural language utterance xi that has n-grams g1, g2 up to gq, a knowledge graph has relationship types r1, r2 up to rt, and an intent label ij that has action A and object O components. For example, find is the action and restaurant is the object component in this example. We set the first n-gram g1 as head, first relation type r1 as relation, and action component A as tail, and link predictor can provide it a score. We repeat this step for all n-grams and take max. And then we perform the previous step for every relationship type in the knowledge graph, and that gives us a t-size vector. That essentially captures utterance to action relationships. Similarly, we compute utterance to object relationships. Computing bidirectional relationships is also important, so we compute action to utterance relationships. And finally, object to utterance relationships. The concatenation of these subvectors form relationship metafeatures. These features quantify the level of relevance between an utterance and an intent label, and they can be computed easily even for unseen classes. Details on training the model that uses these metafeatures are in the paper. Similarly, to see how things work at inference time, please see the paper. Here I am presenting the results on SGD dataset, which is a challenging dataset. Our model outperforms the other state-of-the-art models on both seen and unseen intents regardless of the PU classifier's integration into our model, and this performance is consistent across all datasets. We also present an ablation study and the effect of varying the percentages of seen and unseen intents and the effect of PU classifier on other models and their analysis in our paper. That you will need to see the paper. To summarize, our model RIDE leverages common sense knowledge. It computes relationship metafeatures by analyzing how phrases in the utterance are linked to the intent label via pre-trained link predictor. It combines these features with contextual word embeddings for utterance and intents. Our approach outperforms existing methods consistently on 3 public datasets in a wide range of experimental setups. We are further exploring whether common sense knowledge can boost the performance of other zero-shot tasks. All the related code and datasets are available on this GitHub repository. With that, I conclude my talk.